Hey, good morning, everybody. Thank you. First of all, I want to thank Jerry for inviting me to not only come to the event, but then to come up on stage. Just a little bit about myself real quick before we get into it. I'm here because I need all of you. I represent Sumitomo Heavy Industries in the crane division, shipbuilding cranes. Most of our cranes in our shipyards, both the public and private, are about 50 plus years old. And with our shipbuilding initiative, we do need to improve the infrastructure. So I am here personally on behalf of Sumitomo to find partnerships for manufacturing. And I've heard that the Midwest is a good place to come. So that's initially why I'm here. And I want to thank Sagamore Institute and Jerry and Pat Schaefer for unfortunately getting sick and tagging me to come on up here. So thank you very much. So before we introduce everybody else, I want to introduce them, have them introduce themselves with the first question. The first question being, what is a munition? When I used to think about munitions, flying P-3s with Jerry, we had little Zuni rockets on the wings of the planes, and we'd drop torpedoes out of the bomb bay. But that's the extent of what we did, firing Harpoon missiles, potentially Tomahawks. So I want to ask that question, has that evolved, has that changed? So with your introductions, gentlemen, what is a munition?
Well, I'll echo the thanks to Jay, Jerry, Sagamore for what I believe is now the third Midwest Defense event. I mean, I think it just keeps building each year in terms of not just the quality of the attendees, quality of the speakers, but the importance of what we build here, the recognition that there's value to still continuing to invest in the Midwest. My name is Zach Mears. I lead strategy and business development at Anduril Industries. Ohio native, brief sojourn to DC, spent about 8 years at the Pentagon, returned and have now helping us build Arsenal One, our manufacturing campus just south of Columbus near Rickenbacker Airport. And what we'll build there includes munitions, broadly defined. You know, Anduril's thesis as we were founded was very much on how do we take general purpose capabilities, software, the ability to sense make across different modalities of sensing, understand an operational environment, and ultimately close a kill chain to generate an effect on an object that is concerning. And so for us, a munition is how we're delivering that end effect on the kill chain. One often thinks about it being the thing that either is lug launched, palletized, launched out of a container or tube, and it still may be carried that way. But my former boss, Bob Work, dear friend of Jerry's as well, often got in trouble when I was working with him in the Pentagon for elevating payloads over platforms. What he meant by it at the time was, particularly at an age of automated systems, advancing AI, and the marriage of those with low-cost robotic systems, was that increasingly you could put a density of these platforms in an environment, but what really mattered was the payloads that they were carrying. Our ability to understand the adversary's disposition in time and space, our ability to confound the adversary's understanding of ours, and ultimately the ability to close that kill chain and generate an effect, ultimately seeking to deter them from continuing to advance against their objective. That animates what we do. It also animates what we build, how we design what we build. So look forward to getting more into that.
Thanks, JP. I don't know where Jerry went, but I too want to say thanks. I was meeting with him on battleship USS Defiant and the kit that goes on that ship. And at the end, he said, hey, can you participate in the Sagamore Midwest event? Honestly, I had no idea what it was. So I'm glad he introduced me. So I'm really happy to be here with my colleagues and all of you. What is a munition? Munition has changed so drastically, if not the current event is changing it yet again. To me, a munition is, what do you use undersea that you're going to go after a red with whatever the kit is required. And so we're thinking very differently, developing the right kit to go after technologies undersea. And it's not always something that goes boom. There's non-kinetic effects that we can do in all three domains. Certainly, kinetic effects are important for airborne applications or land-based applications. And as a matter of fact, GA we have a big announcement tomorrow. We have a defense industry announcement in our southeast facilities, so we manufacture a lot in Tupelo, Mississippi. But part of those announcements are the amount of industrial investment we continue to make. We don't accept PE money or VC money. It's self-funded, and so we're going to talk about some of the initiatives both domestically and internationally for co-production. But munitions, as I said, could be a projectile. It could be multiple projectiles that get launched in front of a missile, so you can have multiple targets at the same time. You could have non-kinetic effects, whether it's EW or EA. Those effects obviously are important in the jamming environment. And when you look at what Iran has figured out how to do, they have some very interesting tech that we have a team right now reverse engineering some of the things that we've learned about to see if that's something that our arsenal needs. Personally, I think it does. But we have lots and lots of shortcomings for the supply chain. The supply chain hasn't had to build up like this since the World War II, and my personal concern is where are all the rare earth elements? How are we going to make sure that we can continue that? So I think it's extraordinarily important. I think you're going to have a talk later today by General Grande that's going to talk about how do we restock our reserves. If that happens, then I think we'll be in grand shape. Now, there's other materials that are also equally concerning. And the last thing is we can't have enough missiles or low-cost missiles that provide kinetic effect as a munition. And I think that all of us sitting up here are working on several generations of that tech, and I think you can't overestimate it. The last thing I would say, though, is industrial investment is required. I liked George's discussion. I grew up over 2 decades in a shipyard. So I get the industrial base. I think when I started at General Dynamics, we had 26,000 people in Rhode Island and Connecticut. I left to go to General Atomics. We were down to 7,000. Now they're back up again, about 26,000. You don't make that up overnight. There's a lot of training that's required. So when we talk about starting big factories up, it's all about how do you get the training and how do you get the people. What kind of training do they need? Do they need a degree? Do you have a community colleges providing it? So I hope that's something that we're all investing in today, because there is no more tomorrows. So thanks.
Thanks. If we look at the conflict in the Red Sea region, or we look at the conflict in the Ukraine, I think just by observation, a munition is no longer just a heavy object that goes boom. I think today it's a data-dependent asset. We've got the physical steel and the energetic payload that is just a delivery vehicle for a massive amount of intelligence, firmware, and targeted data. So I think we have to look beyond just the payload and the delivery vehicle and look at the technical data package that is used to manufacture that munition. And if we can't produce it, we technically don't have the capability. If we can't produce it in time for a conflict, we technically don't have the capability. So when you ask me what a munition is in 2026, that's no longer hardware sitting in a depot. It's really a technical data package that we can, at a moment's notice, reroute to available manufacturing capacity across the entire industrial base, not just to the last contractor that produced it.
Great, thanks so much. And a couple of things were just touched on. Supply chain, just-in-time deliveries. I recall prosecuting a Russian submarine. The USS, it was a Russian submarine called the Kursk. And as we are tracking this submarine all through the Atlantic and Mediterranean, my commanding officer would come up to me as the operations officer and say, JP, how are you going to reconstitute my ready? The ready was the next plane 2 or 3 missions down that's ready to go and launch. So that was the emergency asset. How would I reconstitute that? It changed the way of thinking. You have to think well in the future. So if we can just touch on both supply chain and reconstituting the ready, how are we going to reconstitute our munitions that we're using right now in Iran and other areas?
Happy to leap first at that one. I think it gets back to principles about design. As I alluded to in my opening comments, the thesis that Anduril takes to all of its products is a grounding in commerciality. For too long, over the last arguably 2.5, if not 3 decades, the defense industrial base has separated itself slowly and then quickly away from core commercial areas of technical advantage and supply. We seek to ground our product very much in the commerciality of the technical industrial base that exists not just in the United States, but in Western Europe, as well as in Asia with our core partners in Japan and Korea and Australia. And that allows us, as we think about commerciality, to think about building resilience into our product designs. So Fury, our offering to the Air Force's Collaborative Combat Aircraft Program, has a landing gear that can be built in any machine shop in the United States. So how do you think about taking out those bottlenecks that ultimately constrain your sources of supply? We have fuselage composites that are now out to 4 different vendors. We don't reduce ourselves to a single source of supply. So it's not just about opening up opportunities, it's about qualifying other partners into these programs that exist. These are companies that are durably investing in businesses in America, but have not found the right design partner to come into providing their capability into a defense program. So as you think about the challenges of what our operating force demands, oftentimes a high mix of low volume program delivery that's lumpy, that's episodic, you're expending inventory, you're seeking to regenerate that inventory as affordably and as quickly as you can. How do we think about the principles that ultimately allow us to invest in an industrial base, one that exists and then one that should, in order to enable that? And it's, again, why we think about design principles around producibility, which I couldn't agree more with Chad, that allows our program partners to actually have access to the capability at a time, at a cost, and the ability to deliver that capability to the operating force when they need it.
JP, that's a great question. I suppose we're sort of the opposite thinker. 20 years ago, many of our competitor mates were outsourcing. No names mentioned, but one of the largest primes, I was at their facility, 5 or 6 years ago, and I was shocked that there was no CNC machines, that everything was outsourced. And that's a business decision. We did the opposite, so we make about 85% of anything we design so that we can control the quality, we can control the performance, and more importantly, control the schedule so that we can ramp up and down. The challenge that comes with that is you have a massive amount of overhead with the capital that you possess. You have to keep the lines busy enough so that you're not losing money. You have to also continuously train for undersea products, to airborne products, to space products, at least in our case, and energy products such as fission reactors. So we've got a difficult supply chain. We have had the tendency to go look for the supply chains that have given us the most trouble, and frankly, we've acquired many companies so that we could go invest in those supply chain challenges. But if I give an example, when the submarine community needed some help on missile tubes, we said we'll go invest in that. So ahead of demand, we invested, and now we're building payload tubes for Virginia class. But we really were looking at what can we design and build. That's a build to print. We were helping out. And we started investing 5 years ago, really seriously investing on what is a projectile that we can develop that will come out of a common 155 round, and how do we leverage the railgun work that we did 10 years ago. And the net bottom line was we invested about $250 million in the last 5 years developing a new round that can go 4 to 5 times the range of conventional ballistic rounds out of a 155. And we'll stay tuned. We'll have it announced tomorrow on that tech. But in order to do that, we also invested in the manufacturing facility, and we said, it's a maneuvering round, it's a smart round. what is the highest rate that the Pentagon ordered in the past for a maneuvering round, and there's one program. So we built what we call Mystic Village, which is a facility that is ready to use robots to build all of the structural parts. And tomorrow we're going to make announcements about that. It's installed, it's operational, and we haven't received one production order yet, but we wanted to get ahead of it because if industry doesn't invest, when the government needs us, when the Department of War says we need to go ramp up to 10,000 to 50,000 or whatever projectiles a year, we're stopped, and then you have to start the process. It does take years. Contrary to popular belief, you can't just go out and buy 75 CNC machines and install them tomorrow and start operating. Yeah, it takes a long time to install them. It takes a long time to train folks ahead of time, and then you have to program them. And then the real tough challenge is getting the supply chain for things like high-strength steel or aluminums or titanium. And then you've got to go get the printed circuit board parts. It sounds easy. I'll just start up a factory tomorrow and next year it'll be fully operational. It doesn't happen that way. I've been at General Atomics 19 years, and today we are fully operational. But when I started, we had 2 CNC machines that the government owned. Today, we have 75 machines for my business. The government owns none of it. We bought it ourselves, and we can machine up to 180,000 pounds at 18 feet in diameter because the industrial base demanded it, and we had to invest. My colleague talks about going to 4 different vendors. That's absolutely the smart thing to do. You've got to have backup. So for some of the more complex machining, some of the more complex fabrication, we actually invest a significant amount in the Midwest. I checked before I got on the plane yesterday. We've invested about $1.55 billion in the Midwest, making sure that we have second sources for some of our very large fabrications and machine parts. And then the last thing is we spend a lot of money in advance of contract, taking a risk, doesn't always work out well, making sure we go to the industrial base and we keep the demand up so that they don't run out of work. We want to keep having the product come in, and we spend tens of millions of dollars in advance to make sure that those vendors are at least healthy enough to keep supplying the product they need. So I think it's a really critical question to keep the industrial base. Mike, I'm afraid I have to leave to go to this event tomorrow. I know your boss is going to be with us tomorrow, but I'm really interested to know what other industrial investment we can get for capital to help out some of these supply chains. Really look forward to it. Thanks, JP.
Thanks. I think I approached this question from the entrepreneurial perspective. I've been an entrepreneur for 30 years. And for an entrepreneur, cash efficiency is everything. And if I have a very high hurdle to cross in terms of the inventory I have to carry because of specialized materials, or a high hurdle to cross because of compliance or testing, or just becoming qualified as a defense industry-based supplier, am I going to choose to focus my time and energy there, or am I going to choose to focus my time and energy on commercial applications? If we're going to expand the industrial base, we need to make sure that we make it as easy as possible without lowering our standards of quality, without lowering our standards of security, for businesses to do business with the Department of War.
What about data? Can you touch on data a little bit, the data that industry is going to need, and the communications between the Department of War and operations, and the data that you need to reach down into that supply chain to, have enough supply for the department?
Well, that's a really interesting question. The data problem is a very real one. Companies don't want to share data, right? They want to keep it tight, because if I broadcast that one of my machines is down to the rest of the world, what's that do to my customer base? If I broadcast my core IP, how I manufacture a particular product, and that's my secret sauce to the whole world, what's that going to do to my competitive advantage? So, in my opinion, this world is now being more and more driven by AI. And AI has this wonderful quality, but it also has this horrible risk of output containing data on which it was trained. We need a way to control, for companies to share data but still maintain their long-term control over that data.
I mean, that's a big question. I guess consistent with the payloads over platforms theme, as you all know, there's a lot of data that's simply husbanded in systems, and it's either latent, backhauled, never backhauled. We're now moving into an era. I think this is testament to the perhaps a term that is synonymous with other four-letter words. JADC2, how we're generating all the system-level sensor data, ultimately federating it out into those systems that can fuse those multiple phenomenologies into understanding an object, having an unbroken track of an object, ultimately surfacing to an operator who has to make time-sensitive decisions as to whether, and if so, how best to engage that object in some sort of effect. How are we rationalizing this world of ubiquitous data for the operational user, knowing that the technologies and the efficiencies of the sensors that we're putting out into the operational environment today are only compounding that problem. This is a problem that we've been tackling since the beginning of the company. How do you think about the compounding value of openness? So Lattice, which is our operating system, it informs not just how we design all of our products and how those products share and move data across their compute and mission systems environments, but also how others engage with, share data with, and ultimately get bidirectional data out of our ecosystem, whether that is data that is from a product of Anduril's or whether it's a third-party system that's been integrated. And you look at what the Army has been doing over the last several weeks with Operation Jailbreak. This builds off of several successive events and investing in a next-generation command and control platform, all with an eye toward how it unlevers this data that might be trapped in or is latent in its delivery across the joint force. How do we make that system-level data more available? We very much agree with that impetus. The challenges associated with doing it must be tackled, and then it's, once you have all that data, how do you rationalize it in a way that is not paralyzing, especially when you're trying to make time-sensitive decisions under some measure of uncertainty. So the degree to which we are smartly applying both initial kind of deterministic AI and then eventually learning AI to enable that operator still on the loop to have the most informed decision control that they have based on the volume of data that's being presented to them about their environment, the better we're going to be. And I think we're still early innings on getting after that technically and getting that capability and that architecture in the operating force. But the technology's here, and we've got to find a way to harness it and get it deployed.
If I may, JP?
Yeah, please.
Data. There's two kinds of data. One is, in my view, is what's the government giving you for data so you can design, or what data you're getting so that you can manipulate your product. And all too often, a lot of the programs are uber classified. So getting that data, getting the networks in place, getting the folks briefed is a monstrous task. If you do anything in space, 9 times out of 10, you can't do it unless you're over a classified network. So that's a challenge for industry because you have to invest in all the SCIFs and SAPF facilities to make sure you can get that data, and then you have to work the customer over to get the data. Once you get it, sure, now you can process the data. But the second part of it is, what do you do with the data you're self-generating, and how do you protect it from getting taken by the Reds? So as an example, my team is under contract right now for 39 overhead persistent infrared payloads in space. That's a lot of data. How do we get that data down? How do we move the data back and forth? And if you look at where we are, I think we're all going optical. So about 10 years ago, we started investing in optical communication for all 3 domains. We have to get the data as fast as we can and make it as jam-proof as possible. And I think as you look at what the Space Force is doing, that's all we're going to see in the future, I think, is optical links. So now how do you take those optical links and put them on aircraft, whether it's a CCA, Gen 5, Gen 6, whatever it's going to be? How do you get it down to the ship provider? How do you get it down to the ground? How do you get it down to submarines? Or now we're going to have so many unmanned systems. How do you get that data? Regrettably, most of that's classified, but we as industry are working on it a lot right now, and I think that's the future of data movement. The last thing I'll say, if anybody knows how data moves on a program called Thresher, we're fortunate enough that we own the company in Charleston that does that at GA, and at a commercial level, we created a sort of a digital twin of that called Optics, so that we can do that internationally in a less classified environment. So we have a significant amount of AI engineers. That's all they're doing is moving data around. So thanks.
JP, if I could just expand on this one more time, I think we need to consider the expansion of our definition of munitions to include these non-kinetic munitions, right? Whether it's algorithmic warfare, whether it's jamming, or whether it's even just stealing our industrial data. We have CMMC requirements. We have there's a lot of cybersecurity requirements that we have. But I imagine that most of the data about the production of the Tier 2 and Tier 3 components of our munitions do not exist in such a secure environment. And for that reason, I would maintain that maybe our adversaries know more about our industrial base than we do.
Great, thank you. All right, so as leaders in the industry, moving on to another question about R&D. So who's responsible for the R&D to develop and field new munitions? Is it the role of the government? Is it the role of private industry? Is it a combination?
Oh, it's absolutely a combination. But before I answer that question, I'd like to thank either Jay or Jerry for ordering up a moderately cloudy day, because otherwise I can imagine the intensity of this dome would be unpleasant for everyone. So we should all give them a brief word of thanks on the way out. Yeah, I think it's a shared responsibility. I think one of the beauties of the of the American industrial system and the capitalist economy that underwrites it is the willingness to invest left, to explore, to build. And we all do it in different ways. The incentive structures that exist within a privately capitalized company to invest those dollars in early stage development are different than a government lab that's investing taxpayer dollars in government research that might be applicable to a broad range of problems, but needs that protection to be incubated, and then ultimately needs that public good to be distributed to those in industry that could make good use of that technical development. But I think, first and foremost for Anduril, from our start, we believe in applying our dollars into early stage product development. No one has 100% grip on the truth of what is operationally needed. We should have a view. We should be willing to put those dollars into invested development to evaluate whether we have a technical solution that is better than the existing status quo program, whether we have a technical solution that can be more competitive than others that we believe are exploring in that same area. And we should be willing to put those dollars to work and ultimately compete for a program. And the more that we put that left against our understanding of mission, the more that we engage early with the customer, the more as we get into actual defined program requirements, we and our partners in industry will be in a more competitive place. And so as each service in their own way is moving to some form of a marketplace as you get into more commoditized, lower cost robotic systems. It's in our and the government's interest to invest those dollars early, compete those dollars frequently, in public, maybe as Jerry alluded to, obscured in public in Area 52, and ultimately invest in through contract procurement the ability to pull that capability into deployed programs with some competitive cycle that's informed by, in that domain, how should we expect the technology refresh cycles to tell us when we should be competing again? Because you could compete too frequently. 6-month cycles, unlikely, perhaps with the exception of the pace of development of large language models and the reasoning against them. Most technology cycles are not moving that fast. So what's the right incentive for the government to put into industry to reasonably put those dollars to work against their need and not someone else's? And then ultimately learn whether you get rewarded for putting the best solution out there. And I think that comes with a responsibility of industry to invest their dollars in their products today and invest their dollars in the continued development and improvement of those products over time. And it gets married up best when it has partners in government, in academia, that are investing in different time horizons of that same solution. And the more open we are about sharing that problem, that progress, and then ultimately competing for good outcomes, the more likely it is that we'll be delivering a program capability that is meeting an operational requirement that a deployed user has.
Awesome question. Actually, this one is truth or dare. How much are you willing to invest and let the government know you're investing, so they'll just keep letting you invest before they'll give you any money? That's the challenge, right? But General Atomics is in a sort of a unique position. We're the largest privately held government contractor in the United States, which means we have no shareholders that are investing from the market, from the stock market. We don't take PE money, as I said. We don't take VC money. But we believe hugely in making the right investments, as our greatest fear is everything gets so expensive in 2050, we'll be able to buy one airplane a year. That's not a joke. That's what we worry about. So we look 20 years out in the horizon. What do we have to do? And so the government has an easy capability for industry to invest. It's called G&A. You can come up with your own G&A rate, and you can invest in discretionary. Discretionary is the private R&D investment or the private marketing that goes along with those investments, or the bid and proposal money. And in our case, we've elected to have a very handsome G&A rate, which means we're not always competitive when the government's ready to give you money, which is unfortunate because we're already giving them the advanced start. This long-range projectile that I talked about, we put $250 million into it. How do you account for that when you're bidding? The capital that I talked about, that's $1 billion for the capital that we're talking about in the investment for industrial base. That makes your rates higher. But I think we have an obligation as industry to do the startup to make sure what is the art of the possible. Many times we'll invest in technology that the government doesn't know they need because they're not able to always see out. Now, some administrations are great at that. We have rapid capabilities organizations that are very good at that. But in general, I think industry has to go make the first investments. And during the COVID years, we ended up spending not just discretionary, but we had to invest our profit to make sure that we kept pace. And there were so many delays in contracting, it kind of wounds you, but you have to make that investment. And then you hope that the government is ready to take over it after you've proven feasibility of it. We've done something new in the last year. We looked at what another country was doing, another company was doing. We work on many missile programs and hypersonics, and we really wanted to get going with a cruise missile program, and that's yet another sizable investment. Well, we signed an agreement last year with Rafael in Israel, who developed a new cruise missile that will get the benefit of all that development and be able to sell to the United States and to FMS customers. And that deal is still a work in progress. But the point is, they live in a tough neighborhood. They have lots and lots of missile technology, and we get the benefit of 80% of all that experience goes into a missile that we now take over and rebranded and will Americanize. That is a new one for us to see how that's going to work. But I think Rafael's been an awesome company to work with, and it's hard because you got to make tens of millions of dollars investments to make that right. This year we're building another 300,000 square feet in our manufacturing facilities to get ready to build a missile for which we don't have a contract for. We're building out 100,000 square feet for NNSA work for which we don't have a contract for, and we're building out 100,000 square feet for a projectile program for which we have no production contract for. But I think it's industry's obligation not just to do the R&D, but to be ready to get the kit at volume. Because what we've learned in the last couple of years, particularly right now what's going on in the Mideast. We have no choice. We've got to get to higher volumes. So we industry have to start investing in that, and hopefully the government recognizes that when your rates may be a bit higher, but they didn't have to pay for a great deal of that investment. Thanks.
I'm going to up-level the conversation to more of an ecosystem level. When we talk about innovation and its path to scaled production, right? You have raw research and development, you have applied research and development, you have commercialization, and then you have scaled production. And when you look at both the capital and the personnel that are involved in both, in all four of those stages, right? Raw R&D is happening in the national labs and in the university research environments. The path to getting that from raw research to applied research, it's not so well funded, and B, you don't get a PhD for doing applied research most of the time. You get a PhD for making huge progress on raw research. Now, we talk about the path to commercialization. There's this tremendous gap in available capital between raw research and scaled production. Once you get to scaled production, there's plenty of capital available. When you're at the raw research, many professors might disagree with me, but there's ample capital available for funding raw research, a lot of it coming from our national, our federal government. We need to close both gaps, both the capital gap, but also you think about the postgraduate personnel that are doing a lot of that research and where they end up. Do they end up in our US companies, or do they end up back in China or in India where they originally came from? I think both present a challenge that we have to be aware of and manage.
Okay, just brief two-finger. I guess just one point and then one response. I think one way that Anduril kind of surmounts that challenge is thinking about, we think about it from a product perspective. Ultimately, like what's needed to be delivered in order to accomplish a defined mission requirement. And how am I looking left and right about what needs to be integrated into or around that product in order for it to be a critical part of closing a kill chain for an operator. And what leads us to what best positions that product is thinking of it as a general purpose capability. What are the things needed to advance its position in the ecosystem that ultimately, as I am talking to a specific program customer, I can take this thing that I've over 6, 7, 8, 10 years been investing in compounding NRE, and like the benefit that customer gets over that 8 years of successive investment is born in the back of the raw to applied transition based on a thesis that we hold against core mission requirement. It's not against a program requirement. It's like I'm understanding this broad class of missions that either a force or joint forces being asked to prepare for and ultimately conduct. And I'm generating a thesis as how I'm investing in these general purpose capabilities, both software and hardware, that enable that program customer to invest in that remaining gap in order to close on their specific requirement. And I'd say against that, the government does a very bad job at looking into the future. They think in terms of point refinement. They think in terms of 5-year plans, and ultimately most of those 5-year plans are, and I say this having spent my own time in the department defending that 5-year plan, they're very status quo oriented. They're marginal adjustments to the current program over time. It's why program offices like DARPA transition about 3% of their capability from raw to basic into an actual program. We do not make risk-managed decisions to take that technical advancement and put it into the field because we are, for reasons that are understandable, so focused on protecting the status quo. And part of how you break the status quo is by giving an incentive against something that's been risk controlled over years of development that is ready, that with marginal investment actually gives you the ability to test, compare, and evaluate today's program against the possibility of tomorrow's.
You had a couple of great points that are touched on there. Partnerships with the Rafael example, and also what you just touched on, Zach, right there. So in a quick 1 or 2 word answer, as quick as we can, about the timeliness of the capability. How can we accelerate the fielding of innovative solutions?
To speak to one of our shared program customers in the Air Force, a focus on schedule, and we often talk about the iron triangle of cost, schedule, performance, and usually performance becomes this rock that we polish that pushes out schedule, that drives up cost. How you think about time to deliver, and then how you think about the learning cycles over that delivery schedule against a program requirement. I think just starting to flip the mindset of schedule, how you get producibility to schedule, how you lever that to actually generate cost control within your supply chain, leverage over your supply chain because your schedule is more knowable in the next 18 months. I'm actually incentivized to get control and pass through to my subs a clear set of requirements against which I can gain preferred inventory. And I think that gets from thinking meaningfully about time. And we often give time away. Time is labor. I get money off of labor. Many of our programs, the actual dollar is made on maintenance and O&S. How do we actually start to challenge how we think about time as a component of the acquisition strategy for a program? And I think CCA is but one example that we're going to see where focus on schedule is going to meaningfully move us left in terms of fielding product that's needed.
Last night there was a good discussion that talked about the shortage of test facilities, that you have to stand in line waiting to test a new aircraft. That's not the only shortage for testing. Right now we're faced with the same problem for missile testing and projectile testing. We just don't have long enough ranges for the new tech. We have allies that do have long enough facilities or have maybe more capacity than we do in multiple countries, and we tend to forget that. Oh my God, we have ITAR, so that's too hard. Oh, we have to bring a howitzer over to South Africa, or you have to go to New Zealand. We need to be a little bit more flexible and realistic about that and just allow that to occur. The other thing to field technology, I'll give you an example. Last March, certain individuals called us from Indo-Pacific and said they have a really hard problem undersea. Can you solve it? And I said, yeah, we can. When we got back on the phone, I said we have to prove to ourselves that we can operate faster. So here's the deal. We're at war. This is a fake war. We're at war with an adversary, and if we don't deliver this kit within 90 days, we lose, period. So we have to all treat it that way. And I said, we don't have a contract. We're just going to go. Halfway through the program, the customer got on the line again and said, oh, we want to create an IPT. Now, the tech we were developing, we are quite expert at. And my question was, so you guys are now experts at this technology? No. I said, look, we got 45 days left. You go figure out your part, we'll figure out ours. On day 89, we tested the hardware and it worked. However, I wouldn't deliver it until I got paid. I just got paid last week for something we tested July 8th of last year that had to be done in 90 days. The message is clear. We got to get better in the Pentagon. Somebody needs to shake it up a little bit and allow things to occur faster. I know Anduril would believe in that totally. We can go faster, industry, but you got to keep up with this Department of War because get the impediments out of the way. Allow us, trust us a little bit. And oh, by the way, 80% is probably good enough. If we didn't meet the top 10% of requirement, but we're close, let's get it out there and let the warfighter tell us if there's any more they need, because we're really good at doing engineering changes, but do we really need to? Let's go find out. That's my comment.
I'll try and keep this really simple. Accelerate the propagation of information, not information about how we got a certain result, but what results we got. And I think that will prompt the curiosity and the propagation of R&D innovation.
All right, next question here. One of the early lessons learned from the Navy's Red Sea conflict with the Houthis was the mismatch between munitions costs for single engagements. The U.S. Navy saw situations where a relatively cheap drone engaged with multiple multi-million-dollar missiles designed for high-end targets, which resulted in magazines that emptied too quickly. The Chief of Staff of the Air Force has asked for, quote, affordable mass when it comes to munitions. What does affordable mass look like from your viewpoint, and how do we achieve it?
I guess we'll just keep passing it down.
I'm happy to start if you'd like.
No, that's fine. I mean, affordable mass is kind of core to what we do. I guess with respect to that problem in particular, and then we can kind of broaden the notion of affordability. The United States literally cannot afford to cost impose on itself. From the middle of the 2010s, when our forces and our partner forces in the Middle East first suffered from the harassing threats of just Group 1 DJI drones. And then those DJI drones were carrying drop munitions. And then those DJI drones were engaged in swarm-like behavior, engaging in kamikaze attacks on both our distributed as well as our armored forces. And then the Iranians began fielding, what reasonably are characterized as low-cost, slow, low-flying cruise missiles. The challenges that the United States and our partner forces have had is that our air defense systems have been geared toward a higher-end threat for decades. And we did not have the systems distributed as well as the systems that could keep up with the pace of threat that over the years from 2015, 16, 17, 18 evolved from that Group 1 to a Shaheed-like capability that is now, as we all know in this room, replete against the challenges we're facing in Epic Fury, the challenges that our partners in Ukraine are facing as they contend with and seek to roll back Russia's continued aggression and territorial conquest. And how we get to resolving that question is not how are we bringing down the upper tier stack into solving this problem. It is what technologies are available to us today to design up and ultimately think about the way in which we compose and recompose solutions against a threat that's evolving quickly and is diffusing against not just us, but our allies and partners. So how we think about ultimately the design requirement of that system is critical. You can think about it in terms of kind of core bomb costs if you get into the inside the program, and it leads you back to one of the other questions that we started with, the supply chain. So, where are the core bomb drivers of some of the critical interceptors today? It's in the seeker, it's in the warhead, it's in the data link, it's in the radio, and it's ultimately in the propulsion stack. There are ways that we could start solving those cost problems of the bomb today simply by qualifying other suppliers. I know, one of the critical policy and regulatory initiatives by the department in concert with the oversight committees is to qualify and lower the barriers to qualification for other sources of supply that have similar performance characteristics to existing certified, data link enabled, classified programs. How are we opening up those core bottlenecks, ultimately generating competition within the core mission system supply chains of these interceptors and driving competitive cost pressure down? And then there's how do you think about the actual design, not just of the weapon, but ultimately the weapons that you employ to defeat this target. As you think about diffusing that defeat across a wider range of techniques and capabilities, having the exquisite thing with the high PK is not the single solution that you optimize against. You're giving yourself, your operator, a range of solutions to ultimately compose that detect defeat against that. And the ecosystem is driving competitive pressure because you're always competing to bring the next thing into it. This is what we've been doing with SOCOM for the last 4 years. So I think the competitive pressure to bring costs down matters a lot. How you think about it then manifesting in supply chain is something that I think as a group we need to continue to put pressure and focus on.
Munitions is just not always kinetic. My God, we have laser technology today that could be a cup of coffee to shoot down a Shahad 136 instead of a multi-million-dollar missile. This is a new concept for the country, because I don't think we anticipated a $35,000 UAS and what is it going to take to intercept it. We've been studying the Ukraine war, we've been studying the Iranian war, and you can imagine we have, my sister company has a lot of MQ-9s that have had to experience some of these capabilities, and therefore we learn from that. But at the end of the day, you've got to have an asymmetric solution. Why aren't we fielding weapons that are directed energy for real? I'll give you an example. We said if we were on top of the Shahads with an unmanned plane, so nobody's in harm's way, we can put a laser on an airborne platform that's unmanned, and we can outrun them, just keep shooting them down, and you're now spending cups of coffee to shoot it down. We had a program start. At Christmas time last year, a customer calls up and says, we don't have the money for next year. We don't know where it is. I go to the House. They look at what OMB and Department of War did to the reconciliation. They said, no, that funding's still there. Yet here it is June, not a dime. We got to stop putting a bunch of R&D efforts into the spin loop. Let's not put it in the dryer. Let's get it out there and start using it. Because what we're doing is very effective, but it's god-awful expensive, and it's not going to change. It's very hard to intercept. I don't think we're going to get a lower cost to intercept. At least I don't know how to do it, unless it's like a railgun projectile. You can at least meet that. Well, we shut down that program a few years ago, and now it's back on again. At least the Japanese have been back at it again. I think these two technologies are technologies that I hope that the Department of War really allows us to get out there and start using it today, not tomorrow.
To me, the cost reduction all boils down to modularity. And if you think about making a munition truly modular, and such that the Department of War itself could put together component A with component B with component C to form a munition, that modularity may exist within a prime contractor, but it doesn't necessarily exist across all of our suppliers. And somehow we have to, and this may be a little bit of a Pollyanna view, but at the end of the day, we need to allow the Department of War to assemble its munitions in a very modular fashion by looking at what's available, in what capacity and in what speed, and bringing those three things together, the sensors, the propulsion, and the explosive together in a way that makes the most sense for what we've got available.
Now, very good. It's sort of like the NATO 5.56 round, make it modular, make it on all different platforms. You want to comment on that as well? So the cost of these munitions versus the cost of the platforms. Can I get comments on that?
Yeah, I mean, we're hosting a few officials at our Arsenal One manufacturing campus in Columbus yesterday, and one of the areas where we were continuing to receive both question and pressure, even while our interceptors are, I say, relatively more affordable than the existing programs of record. It's still arguably not enough as you think about getting to parity or something near it. It could be somewhat reductive, though, if you're actually thinking about one-to-one replacement. You're also thinking about the value that interceptor is providing to either the area or the asset it is protecting. So you can get into a bit of a turtles all the way down problem if you're solely focused and you believe that the problem is purely the cost of intercept. It is the cost of intercept relative to the value of the operation. And we try to keep that in mind. That's trade space. We should have a conversation about how cheap is too cheap, where you've narrowed the ability to missionize that capability for other purposes, be it today or over time. We think a lot about those constraints, how you maintain degree of freedom against mission requirement. And it's again why I'll come back to the general phrase, general purpose, why we think about keeping our degree of freedom open as we think about both the integrated operating system that will command, control, and ultimately generate effect of either our or someone else's product, and then ultimately how we think about a product design that enables us to take two different engine types and qualify them on the aircraft, take two different actuator types and qualify them on the aircraft, take two different warhead types, qualify them on the aircraft, the munition. That over time generates more competitive pressure, less reliance on those single sources of supply, and ultimately gets you to an equilibrium relative to that supply and demand against mission requirement that gets you to a reasonable cost, whether the basis of comparison is one-to-one. At times I worry that overly focusing on that leads you to get to solutions that are sub-optimized relative to what that system could be capable for.
It really depends on what the mission is. If you're trying to go deep into somebody's country, then it's going to be an exquisite platform, whether it's the B-2 or the B-21 or planes that we won't mention here. You really have to have the right platform. But in general, for the two ongoing conflicts, I think you want to launch missiles at them, just put it in a Conex container. You don't have to make it fancy. Move the Conex container around. If you want to have a low cost and you don't want to be threatened by getting killed, there's plenty of unmanned aircraft now that can launch, and the operator can be sitting in the United States at some base. It's away from harm. It's not that difficult. You really can put directed energy, whether it's high power microwave or a laser technology, and do the same thing. So the platform is really dependent on the application. Let's not forget there's undersea munitions also. We spend lots of money on torpedoes, but you can do, we believe, low-cost UUVs that you can put really new kinds of kit on it to do similar missions. You may not need to spend a million-dollar torpedo. You might be able to do it with a $50,000 UUV, and you can get those UUVs there not on a nuclear submarine, but on other carriers that can go from San Diego Harbor to the Spratly Islands and never disturb the ocean if you have the right power and energy approach. We're doing it. We're developing those technologies on our own. We haven't released them yet, but we applied some of the efforts we've seen on large displacement underwater vehicles as well as XLUV, but we need to go farther. We need to have multi-months, not multi-days for undersea, and then let's use kit. Let's not think we always have to use expensive, because that's just an interceptor underwater. This whole thing with these low costs, I mean, it's brilliant, right? Lucas, whatever they're doing, hopefully they're being successful with a mirror image of the Shahads, but the intercept is still the big problem, and you're going to have to carry it on aircraft if you got to go in country, and then what is that aircraft going to look like? Again, if you don't have to have deep penetration capability, use whether it's CCA in the future or use whatever assets. There's plenty of companies here today, including our own, that provides that low-cost kit with long endurance that can happen, and it's very autonomous. So again, we just need to use the right vehicle.
Perhaps we shouldn't be looking at per unit cost, but we should be looking at what is the cost of the overall program when we are doing it at scale on demand. Right? When we have this surge in demand that we've had over the last 3 months, how rapidly were we able to get Patriots back to replenish the stockpiles that we depleted? I think at the end of the day, the cost isn't just the per unit cost. It's what's the lead time for scaled production.
And that leads back to our supply chain and our agreements and our partnerships. All right, one final question. We're here at the Midwest Defense Conference. What is it about this region that is attractive to munitions development, production, and perhaps even testing? And I think we touched on that. What can this region do to improve its value proposition to munitions developers and producers?
Yeah, perhaps as evidenced by the fact that a little over a year and a half ago, we made an announcement that we're building a critical manufacturing facility for Anduril in south central Ohio, just near Columbus. So 5 million square feet, eventually under roof, 4,000 folks producing many of our products. We chose to come to Ohio and not to Texas, not to Arizona, not to Alabama, not to North Carolina, not because they don't offer qualities of their own, But as we looked at the things that mattered most to us at the time of the decision, it was the ability of a state and a site to move at our speed. It was the accessibility of workforce relative to how we design our products. So of those 4,000 individuals, upwards of 85% will be technicians. Those technicians, over time, as we think about the scaled production on our line designs, can come out of a technical school or college in Central or Southeast Ohio, and with 6 weeks of certification, work on many of our products, not just one. So again, as we think about the demands of producing responsively to need at an affordable price with the right partners, there's a durability, a desire, an accessibility, and ultimately a speed at which the Midwest will run if you bring them in the right way. And our experience over the last 18 months, and I believe over the next decades of operation of that campus, will prove out that we made the right decision coming here. They're enabling us to deliver against critical programs today as we're getting responsive requirements and UNs and JUONs as a result of Epic Fury. We are able to respond to scaled production requirements for existing systems, moving secondary production lines here, training a workforce that we've already hired now across product to produce secondary lines. We've been able to prove out that thesis in Ohio and feel comfortable that others should be willing to make a similar bet.
So I said earlier that we've invested $1.55 billion in the Midwest companies because we want to make sure we have a backup source for what we do. We're admittedly manufacturing in the state of Mississippi, and I can't say how much great support we get from Chairman Roger Wicker and from Cindy Hyde-Smith. So I don't see us. And by the way, the governors have been awesome. However, we do have facilities in the Midwest, in North Dakota, not my business, but an affiliate, General Atomics Aeronautical Systems, and I don't think they're going anywhere. They're just building up. We do a lot of work here, and the academia and the customer base is just critical. So we're going to continue that, and because of the massive investments we made elsewhere, it would take another investment like that, and maybe 10 years from now that will be required, and we're always looking around for other states. I would say, though, that I don't want to admit this, but I'm going to, all the big CNC machines that we installed, it takes a special skill. Either you come from the Gulf Coast working on oil rigs that know how to machine these things, or you buy from the Midwest. So we have relocated great talent to our Southeast operations, whether it's in Alabama or in Mississippi, and we'll continue doing that. From an academic standpoint, we try to give money to 5 to 10 colleges or universities every year as a gift so that we can develop more tech together. And certainly Purdue has been one of our schools. I think one of our directors is on a board with them. We really do like the hypersonics capability that we've shared, going back and forth with some of these institutions. And the last thing I will say, I have to give a shout out to Fermilab because we have a major program we're working with them called Muons to Electron. It's really geeky stuff, but the relationship and the technology, that's what we do for a living. So we've got to make sure we continue those things. So thanks.
I think there's 3 components that we have working in our favor. One is our research institutions. We've got some of the best research institutions that are cranking out some of the top research in the world right here in this 5-state region. We have a very business-friendly environment that is conducive to growth, that's conducive to entrepreneurship, and I think that favors the production of munitions quite well. I think the last is our skilled workforce, and if you look at some of the statistics that Dave Tomelis offered yesterday, in this 5-state region, which is smaller geographically than either Texas or California, we have about twice or 3 times as many skilled workers, the cost of living here is such that those skilled workers can still have a very, very nice lifestyle.
Well, I just want to say I noticed that earlier Jerry and George took great pains not to mention the Ohio State University, and so I just wanted to give a shout out to my alma mater. Amongst the five, I just want to echo Chad's point. From 4 years to 2 years to the technical colleges and centers, the density of workforce from raw to applied to ultimately production. You'll have a hard, even if you're relocating it, have a hard time finding a better place to invest in that talent and ultimately to hire it into your businesses than the Midwest, and we're fortunate to be here.
All right, thank you very much. With that, I believe the panel discussion is concluded. I want to thank everybody here. Again, Jay, thank you very much for the invitations and this incredible event. And now that the sun is out, I think our panelists want to go get some lunch or something. Thank you very much.